Hello everyone, this is Preeti. Welcome back to my YouTube channel. Well, this video is the continuity of AutoML playlist. As we know that AutoML helps us a lot by automatically selecting a right algorithm and by automatically doing hyperparameter tuning. So AutoML saves a lot of time. Well, we are done with what AutoML is, and we have done two AutoML frameworks. The first one was AutoML, and the another AutoML framework we are done with is H2O AutoML. If you have not watched those videos yet, I will provide the link in the description below. Well guys, if you have not subscribed my channel yet, please subscribe the channel to stay updated. Well, in this video we are going to talk about AutoSklearn. So first of all, what is AutoSklearn? AutoSklearn, as we know that it is an automated machine learning toolkit. It is actually a drop-in replacement for scikit-learn estimator. Okay, what AutoSklearn does, it optimizes the hyperparameters automatically along with selecting the right algorithm for your dataset. Well, I have already told you it is built around scikit-learn in machine learning library. It is just drop-in replacement for scikit. It leverages recent advantages in Bayesian optimization, meta-learning, and ensemble construction. So let me describe these words first. Bayesian optimization is used to select best hyperparameter as it uses probability model of objective function. Well, we know that there are mainly four types of hyperparameter optimization methods in machine learning. The first one is manual search, then random and grid search, and another one is Bayesian optimization. It differs from random search and grid search because it improves the searching speed using past performances, whereas grid search and random search, they don't do past evaluations. In simple words, in layman words, I could say that Bayesian optimization is just like a manual search. Like you can say that manually optimizing the hyperparameter of our regression model. Firstly, you would try a set of parameters, then look at the result and change one of the parameter, and then again rerun comparing the result. So by doing this, you will go towards the right direction. So Bayesian optimization does a similar thing. So it learns from the you can say past hyperparameter affects the how past hyperparameter affects the future decision. In comparison with random search or grid search, they don't take into account the past performance while determining new hyperparameters to evaluate. So we could say that Bayesian optimization is much more efficient as compared to others. Now there comes meta-learning. Meta-learning is, we could say that it is a subfield of machine learning where automatic learning algorithms are applied to metadata about machine learning experiments. Then there comes ensemble construction. Ensemble, if we explain it in simple words, is just a group of things, or I could say that group of people that makes complete unit. So in machine learning, when we use multiple learning algorithms to obtain better predictions, that we call it as ensemble construction. Now, I have already told you that AutoSklearn optimizes the hyperparameters automatically along with selecting the right algorithm for our dataset. So these are the main features of AutoSklearn. So you don't have to search any algorithm, as well as you don't have to do any hit and trial for hyperparameters. AutoSklearn will automatically do it for you. Okay, the main modules are AutoSklearn.classification and AutoSklearn.regression. It will make use of these modules to automatically select the right algorithm under regression or classification task. Here is an example how this AutoSklearn is built. So for building this, you have to use AutoSklearn.classification or AutoSklearn.regression if it is a regression problem. After importing this class, then what you are doing, you are just loading your data here, and after loading the data, you will do train test split. Well, in this AutoSklearn.classification.AutoSklearn classifier, you can also give a time limit here, and after that you are fitting your data into AutoML and then doing a prediction for your dataset. Don't worry, we will do a practical implementation of this classification as well as regression task in Google Colab. using AutoSklearn. Now let's have a look at their official documentation. So I will provide the link of this AutoSklearn documentation in the description below. Okay, so here is their official documentation. You can find everything from here. So let me show you an APIs main modules. So you can see that there are two main modules, classification and regression. Okay, before actually these main modules, I would like to tell you a few things about installation. While performing AutoSklearn, you must have few requirements that should be fulfilled because when I started using AutoSklearn in the beginning, I got stuck because my pandas version was the latest version, but it accepts only pandas below 1.0. So these are the requirements. You can find the link here, as well as there are certain requirements. You can find everything from here. So now let's come to main module. So you can find certain parameters, you can define certain parameters what you want your AutoSklearn module to do. So here you can find time left for this task, which is actually you are telling it to run for how many seconds. By default it is 3600. You can define it by yourself as well. Then there are certain more parameters like per runtime limit, means you want your each model to run for how many seconds. You can define here it as well. Well, it is important to give a time limit. We know that accuracy can be increased by increasing the time limit. In real world scenario, you can give any value, any higher value, but when you are doing just practice, and particularly in this example, I am just giving a few minutes time, as if I don't give it, or it will take by default 3600 minutes, it will keep on running for 3-4 hours. And there are other few parameters as well that you can use, such as include estimators if you want to use, or if you want any pre-processing, or you don't want, you can see all the definitions here. They are explained very well. If you want ensemble size, number of models, added to the ensemble built by your model, everything is explained here beautifully. Then this is all about classification, and here is the regression. Same thing, here it is time left for this task per. Everything is explained here. I just want you guys to explore it more and just try it on your own models to get more familiar with this. Now let's come to the practical implementation. Well, AutoSklearn has one drawback, as we can see that in AutoML and H2 AutoML, they do all kind of data pre-processing, even conversion from categorical into numerical. But in AutoSklearn, this is not the case. It does some kind of data pre-processing, but it doesn't convert categorical into numerical. So here I am going to use the some inbuilt dataset in AutoSklearn, such as Boston dataset. You can use any other dataset as well, such as Iris or something. You can also use your own dataset, but you have to do that pre-processing, such as converting the categorical into numerical, and then none values. You have to replace those none values. You have to do all that stuff by yourself. So there are the requirements. I have already told you there are certain requirements that you should look for before before running AutoSklearn, before installing AutoSklearn. I have already installed it, and sometimes you have to run this command twice actually. Fine, I don't know why, but this happens with me. Now after that, what I am doing, I am importing sklearn dataset, as I am going to use some inbuilt dataset from sklearn library. So then matrix to get the calculation, matrix calculation. Then I am going to use AutoSklearn.classification as classifier and regression as regressor. You can also use it as it is during AutoSklearn model building, but I have defined it as classifier and regressor. And then I'm going to use train test split, importing train test split. Here I'm going to give you an example for regression problem using that inbuilt dataset, Boston house dataset from sklearn library. What I am doing, I am just loading the Boston dataset, and I am splitting the dataset into train and test data. After this, I am passing that data into AutoSklearn. here I'm using AutoSklearn.regression. So I'm here giving as regressor because I have already defined it as import AutoSklearn.regression as regressor, or after that I'm just limiting it because I want only AutoSklearn to run for almost 2 minutes. Okay, and then for each model I want it to run for 30 seconds, sorry, 120 seconds, and for each model I want to run it for 30 seconds. Here I am training the model, and after training the model I want to evaluate the model. So I am using R2 score matrix to get accuracy. Then if you want to look your models, you can also use this command show_models to get all the details about the models that AutoSklearn has used. Now let's come to AutoSklearn.classification problem. Sorry, this is not regression, actually this is a classification. Well, in this classification problem, I have taken a breast cancer dataset from Sklearn library. So here what I am doing, the same thing, I am just loading the data, and after that I am splitting it into train test split. Then I am using AutoSklearn.classification.AutoSklearn classifier. So I am just passing that training data into AutoSklearn. Here I am using few more parameters such as resampling strategy. I have put it as hold out. Then I am passing the arguments such as screen sizes 0.80. Then I am just fitting the data for training. After training I have done prediction, and I am just getting an accuracy score of 96%. You can also do that simply, just simple pass it without giving this resampling strategy and resampling arguments, and you are getting actually more accuracy, that is 97%. Well, the purpose of using resampling strategy is here actually I am getting 97% data, and here I am getting an accuracy of 97% accuracy, and here I am getting 96% something accuracy. So if in case you don't want your data to be get overfitted, so you can use resampling strategy. Resampling strategy is the strategy to avoid the overfitting. So it is actually optional. By default it is holdout, but you can use also cross validation or any other technique, but here I am using holdout. With resampling strategy, it is important to give the strategy arguments as well. You can give a train size, or you can give a shuffle, so anything you want, fine. So it is used mainly to avoid overfitting. Yeah, well, there are certain more parameters. You can also include estimators or exclude estimators, or if you are using PCA, then you can include preprocessor or exclude preprocessor. It depends on you. I have already told you there are many parameters. You can just explore by yourself. Then apart from that, AutoSklearn internally used a holdout set of training set to estimate the quality of training model. So based on this holdout validation set, it reports a validation score that you can get by using this print_statistics, and you can also have a view on the models that AutoSklearn has used. So here is a list of all the models, fine. Apart from that, you can also get a confusion matrix as well, fine. Here is the confusion matrix, it is giving me. Then you can also have a look at precision score, recall score. You can also build a heat map or whatever you want. There are so many things you can explore with the help of this AutoSklearn. So this is all about AutoSklearn, and just remember one thing, guys, there are few limitations with AutoSklearn, such as it doesn't do any categorical conversion into numerical. It does some data pre-processing, but not everything. It is not like AutoML or H2O AutoML. Moreover, you can use it for not for huge data sets, such as you can't use it for deep learning. It is good for machine learning, but for deep learning I don't recommend it. So this is all about AutoSklearn. Okay, please click on like button if you really like the video. You can dislike it as well, and if you have not subscribed the channel, please subscribe it for more videos. Stay tuned. Bye bye. Thank you so much.